let's keep working on this worksheet. Let's do a few more. So my goal now is let's do glutamic acid and let's do phenylalanine. We'll do these two. All right, so we're going to start with phenylalanine. First thing that I want you to do is just put in your skeleton of what this is going to look like. And I also want you to think about what's going on with this pH. This is a pH that is less than 7, which means that you need to have, wait a minute. What's going on with valine? Why did I put a charge on that little guy? Okay, so back to this one. pH of less than 7, which means that you need to see positive charges only. No negative charges allowed. So right away, we know that our acid group needs to be COOH and our amino group needs to be NH3+. So what about the R group? In order to keep from going back and forth and back and forth and back and forth, I want you to have separately right now, pause the video if you don't have this, get a table of amino acids handy. Open your book up to it or pull one up on the internet so that we can look at the R groups together. So find phenylalanine and what that looks like. And when I'm looking at the R group for phenylalanine, all I see, and if you can't find it yet, pause it and then restart when you find it. All that I see are carbons and hydrogens, which means that phenylalanine is neutral and the structure of its R group is not affected by the pH of the solution. So we are just going to draw that R group in just like that because it's not affected by the solution's pH. So let's try this one too because I feel like we're on a roll. So now we have threonine and we're going to start going like this, just getting ready for the general structure. And we're going to look at our pH. What is our pH? It's less than 7. So that means we need to see positive charges only. So that means in terms of the amino and the acid, we need to have COOH and we need to have NH3+. What about the R group? Pause it, go find threonine on your table of amino acids. When I am looking at threonine, I see an oxygen in the R group. I see that OH on there, but I don't see a COOH or a COO, so it is not acidic. It's polar, but it's polar neutral. So that means that its R group is not affected by pH. The R group is only affected by pH if it's one of the basic amino acids or one of the acidic amino acids. The acidic amino acids, aspartate and glutamate, or aspartic acid and glutamic acid, that's what we're looking at next. So next up, we have glutamic acid. We're going to start with the general structure of the amino acid, getting ready to draw this guy in. We're dealing with a pH of 1. That's acidic. So that means we're only allowed to have positive charges. So that means that our COO for the amino and the acid part, COOH and NH3+. What about the R group? Find glutamic acid, also called glutamate. Find that on your table and take a look at what that R group is. Do you see that R group, CH2, CH2, COO minus? That minus charge is not allowed. We're at a low pH that only allows for positive charges. So when we draw this R group, we cannot draw it COO minus. We have to draw it COOH. Remember, the way that we get rid of a minus charge is by putting a hydrogen on there. Let's do isoleucine because I feel like I'm really in my jam here. So isoleucine, I'm getting ready for this. I've got this all drawn up. What is happening with my pH? That's above 7. So that means I'm allowed to have negative charges because my pH we're up here. Above 7, negative charges allowed. So in terms of the amino and the acid group, I can have COO minus, but I cannot have NH3+. I need to have NH2, no charge. What about the R group? find isoleucine on your table, look for it. And when I look at the R group for isoleucine, I see carbons, I see hydrogens, that's all I see. So that is a nonpolar R group, and nonpolar R groups are not affected at all by pH. So we just copy this one down exactly the way that it is.